and welcome to another video. Today we will be learning about arithmetic and geometric sequences. First of all, let's look at this definition. A sequence is a function from the whole numbers to the real numbers. What does that mean? That means that our input numbers are always going to be whole numbers. As you can see, you have some examples of whole numbers. So 0, 1, 2, 3, etc. You can go up by 1 and then continue all the way to infinity. When you input your whole numbers, you can get a real, or you will always get a real number as the output. So your outputs do not have to be single whole numbers. They can be a square root, they can be a fraction, they can be whatever answer you get after you plug in into your equation. As a result, when we graph a sequence, we will have points, but we cannot connect those points together to form a line or a curve, because when you have the sequence, again, you're only inputting whole numbers. So this is an example of what a graph of a sequence would look like. Again, they're isolated points that are not connected to each other because you're only inputting the whole numbers into your function. In example number 1, it says consider the sequence defined by a sub n equals 4n minus 3. If they give you the equation, it's super easy to find missing values. So here they're basically asking you for the first term on the sequence, and they're asking you for the seventh term in the sequence. So when I do this, I need to find a sub 1, and then all I need to do is replace my n with this variable, which is 1. So this a sub n represents the input value, and then whatever answer you get from it will be your output value or your a sub n. So here I'm looking for a sub 1, so I'm going to do 4 times 1 minus 3, which will be equal to 4 minus 3, which is equal to 1. So I'm going to say that a sub 1 is equal to 1, or I can say that the first term on the sequence based on the subscript is equal to 1. I'm going to do the same thing for a sub 7. So I'm going to do 4 times 7 minus 3. 4 times 7 is going to be 28. 28 minus 3 will be 25. So I'm going to say a subscript of 7 is equal to 25. Again, it means that the seventh term in the sequence is equal to 25. In this course, we will study two important types of sequences. The first one is going to be an arithmetic sequence. When you think of arithmetic, think of addition. And then we're going to talk about geometric sequences. When we talk about geometric sequences, think about multiplication. We will look at arithmetic sequences first, and then we will learn about geometric sequences second. When we're talking about arithmetic sequences, we have a property of successive terms. So successive terms have a common difference or a constant rate of change. We can write an example of an arithmetic sequence, so 2, 5, 8, 11, etc. And we can see that to get from the first number to the second number, I have to add 3. To go from 5 to 8, I have to add 3. And to get to 11, I have to add 3 to 8 as well. So that is called the common difference, represented by the letter D. Your common difference can be positive or negative depending on the situation. Here we have an example where D is equal to positive 3, which means we're adding 3 after each term, or we're adding 3 at a constant rate because the number that we're adding doesn't change. We have some formulas and equations that we need to memorize. The one that I want you to focus on is going to be this one, because you can get this first equation by plugging in k equals to 0 on the second equation, and it will be the same equation. A sub 0 is going to represent your initial value. Your D, we already talked about in the previous box, which is going to be your common difference. And then your A sub k is going to be representing the kth term. So we are going to be talking about two different variables on here, n and k. So they're basically both variables used for input, but since they are different, we're using two different letters to represent them. A few notes. Arithmetic sequences behave like a linear function, except they are not continuous. Like I said, we can only input whole numbers in, so that's why the points are isolated or separated from each other. Increasing arithmetic sequences increase equally on each step, or you can think of it as the slope always stays the same. Um, let's look at the first example. They're asking us to create the graph for the sequence a sub n equals 3n plus 1. So what I'm going to do is I'm going to create a table. I'm going to put my input or n on the left, and then I'm going to put a sub n on the right. After that, I'm going to plug in 0, 1, 2, and 3 as my input values, and then I'm going to replace those into my equation to get my output values. So when I do 3 times 0 plus 1, I get 0 plus 1, which is equal to 1. So that will be my first point, 0, comma 1. When I plug in 1, it's 3 times 1 plus 1, which is 3 plus 1, which is 4. Same thing for the next one. I'm going to input 2. 3 times 2 plus 1, which is 6 plus 1, which is 7. So I'm going to go ahead and do 1, 4. And then I'm going to do 2, 7 on my graph. When I do 3, I get 3 times 3 plus 1, which is 9 plus 1, which is 10. Again, I can't put it because it only goes all the way up to 8. But you can see the linear pattern on the numbers already because this is an arithmetic sequence. Again, do not connect them. I was just showing the shape of the graph. Example number 2 says for each of the following, determine if the sequence could be arithmetic. If yes, identify the common difference. So the easiest way to do this is to create a table. I'm going to do n and then s of n. Then I'm going to start with 0, 1, 2, and 3. After that, I'm going to be plugging in the input values, which are 0, 1, 2, and 3 into this equation. So 0 squared is 0. 0 minus 3 is negative 3. For the next one, I'm going to input 1. 1 squared, which is 1. 1 minus 3, which is negative 2. For the next one, I'm going to input 2. 2 squared, which is 4. 4 minus 3, which is 1. And for the last one, I'm going to input 3. 3 squared, which is 9. 9 minus 3, which is 6. I am looking for a common difference here. So that's what I'm going to do. To get negative 2 from 3, I have to add 1. To go from negative 2 to positive 1, I have to add 3. And then to get from 1 to 6, I have to add 5. These are my numbers to get to the next one, or my differences. They have to be the same number in order for this sequence to be arithmetic. So I notice that the numbers are different, so I'm going to say S of n is not an arithmetic sequence because there's not a common difference. I'm done with that problem. I'm going to do the same thing for B. Again, create my table and S of n, 0, 1, 2, 3. And then I'm going to input those numbers in. So when I plug in 0, it's going to be 6 minus 2 times 0. 2 times 0 is 0. And then 6 minus 0 is 6. When I plug in 1, I'm going to do 6 minus 2 times 1. 2 times 1 is 2. 6 minus 2 is 4. When I plug in 2, it's going to be 6 minus 2 times 2. which is 4, or 6 minus 4, which is 2. Next one, I'm going to plug in 3. 6 minus 2 times 3, which is 6, or 6 minus 6, which is 0. When I do that one, to go from 6 to 4, I need to subtract 2. To go from 4 to negative, to go from 4 to 2, I need to subtract 2 as well. And to go from 2 to 0, I need to subtract 2. So I know that S of n is an arithmetic sequence because the common difference is negative 2. And then I'm done with that one. This one is a little bit easier because they're giving me the output values. You can do this by going from right to left and using the opposite operation, which in this case is subtraction. So I can do 13 minus 8, and then that will make it a little bit easier, which is positive 5. And then for the next one, I'm going to do 8 minus 3, which is positive 5. For the next one, I'm going to do 3 minus negative 2. I have a double negative, which will make it positive, giving me also 5. Same thing for the last one, negative 2 minus 7, double negative, which will make it positive, which in this case is also 5. So this is an arithmetic sequence, and my common difference is equal to 5. You can write it like I did on the other ones. I'm just writing it like that to save a little bit of time. For this one, I'm going to do the same thing. 5 minus negative 4, which is going to be plus 9. The other one is going to be negative 4 minus 3, which is negative 7. Since these two numbers are different, I know that this is not an arithmetic sequence. Again, because there is no common difference. Common means the same. These are already different, so I don't have to continue to the next one. Okay, example number 3 says let a sub n be an arithmetic sequence, that's important, with a sub 3 equals 8 and a common difference of negative 3. Find an expression for s of n and use that expression to find a sub 12. So what I'm going to do is I'm going to go back and write this equation that I circled at the beginning of my problem. So a sub n equals a sub k plus d times n minus k. I'm going to be working with the variables n, k, and d. D was given to me, so that makes this problem a lot easier. And has to be part of my first answer. So that means that this right here has to be k. So again, the k will be your subscript, which is 3. And then a sub k, also known as a sub 3, because I know that k is equal to 3 based on what I wrote here. I know it will be equal to 8. I don't want to write a sub 3 because I already have it here, but I know that a sub 3 and a sub k are the same thing. So now I'm going to start plugging in. So a sub n is what I'm looking for. A sub k is equal to 8. My common difference is negative 3. And then n minus k, which is equal to 3 based on that. I can simplify this equation a little bit. So a sub n equals 8. When I multiply negative 3 times n, I get negative 3n, and then negative 3 times negative 3 gives me positive 9. I can combine these two because they're like terms, and they're on the same side. So I know that a sub n is equal to negative 3n plus 17. After that, they want to find a sub 12. So just like I did on the first problem, I can use this equation and replace my n with 12. So what I'm going to do is I'm going to start plugging in and then solve. So I'm going to do a sub 12 equals negative 3 times 12 plus 17. So a sub 12 is equal to negative 3 times 12, which is negative 36, plus 17. And then I just need to simplify that. So a sub 12 is equal to 36, negative 36 plus 17, which is going to be negative 19. And then that will be my second answer that I need. So the question was asking me for two different things. Example number 4 is going to require a little bit more work because it says let a sub n be an arithmetic sequence where a sub 12 is 7, a sub 6 is 9. Again, find an expression for a sub n and then use that expression to find a sub 24. So what I'm going to do is I'm going to label these two things since I don't have d and use them to find d. It always helps if you look at the subscripts, the larger one should be n and the smaller one should be k. It simplifies your life because it will save you from having a negative. So here I'm going to do k equals 6 and a sub k. I just did this backwards. N equals 6 and a sub n equals 9. K equals 2 and a sub k equals 7. I'm going to start by writing my equation. A sub n equals a sub k plus d times n minus k. So a sub n I know is equal to 9. A sub k is equal to 7 plus d times n, which is 6 minus 2 from k. After that, I know that 6 minus 2 is equal to 4. And then I end up with 9 equals 7 plus 4d. I need to subtract 7 from both sides, so that will give me 2 equals 4d. Divide both sides by 4, and then I get d equals 1/2 when I simplify. After that, I'm going to ignore this because I need a sub n. So the n's are not important anymore because I'm going to write an equation. So a sub n equals a sub k, which is 7, plus d, which I just found, which was 1/2, times n minus k, which is 2. After that, I'm going to distribute this 1/2, and I'm going to get a sub n equals 7 plus 1/2 n, and then 1/2 times -2 will give me -1. I can combine these two and say a sub n is equal to 1/2 n plus 6. After that, I can use that equation to solve a sub 24, which is going to be 1/2 times 24 plus 6. That will be 24 times a half, which will be 12, plus 6, which will be 18. So I know that a sub 24 is equal to 18. So these are the two answers for that problem. The next one is giving me a different representation. It says several terms of the arithmetic sequence a sub n are shown above. Find an expression for a sub n and use that expression to find a sub 17. So again, these points represent input and output. So I'm just going to pick two of them and circle them, and that's what I'm going to be working with. Again, these are going to be your n's at the bottom. So I have n equals 3 and n equals 1. The larger one has to be n. The smaller one has to be k. So here I have a sub n on this side of the graph, or your output. So I know that a sub n is equal to 2. Same thing here, I have the output right here, which is equal to 6 for k. So I know a sub k is equal to 6. So now that problem looks very similar to the problem at the top. So what I'm going to do is I'm going to write my equation, a sub n equals a sub k plus d times n minus 1. And then I'm going to plug in. I know that a sub n is 2. A sub k is equal to 6. I don't know what my common difference is. That should be okay. And then n is 3, and k is 1. So same thing as before, 3 minus 1 I know is 2. And then I'm left with 2 equals 6 plus 2d. Subtract 6 from both sides. I get -4 equals 2d. Divide both sides by 2. I get d equals -2 as my common difference. After that, again, I'm going to ignore this because I want a sub n as my equation. So a sub n equals a sub k plus d times n minus k. So a sub n equals a sub k, which is 6, plus -2 for my common difference times n minus 1. After that, I'm going to distribute a -2 to both of these terms. So I know that a sub n is equal to 6 minus 2n plus 2. Combine the like terms, a sub n equals -2n plus 8. And then they wanted me to find a sub 17. So I'm going to do -2 times 17 plus 8. 2 times 17, which will give me -34 plus 8, which will give me a sub 17 equals -26 as my second answer. Okay, now let's look at geometric sequences. So some important information, property of successive terms. Successive terms have a common ratio or a constant proportional change. So that means that they're going to be increasing by you multiplying by the same number. So let's write an example. 2, 4, 8, 16, 32, etc. So here I have a common ratio of 2 because when I multiply 2 times the ratio 2, I get 4. When I multiply 4 times the ratio, I get 8. 8 times the ratio 2, I get 16. 16 times the ratio, I get 32. This is the common ratio represented by the letter R. Again, we have formulas or equations to work with. This one can be created by plugging in k equals 0 on the second one. So we only need to memorize the second one. I'll be working with the second one as I do the problems. Again, g sub 0 means the initial value. R is, we already talked about that. That's going to be the common ratio. And then g sub k will be the kth term. Same as before, I have the two variables n and k, and they both represent input variables. When I look at geometric sequences, they're going to behave like exponential functions. Again, they are not continuous. They're going to be isolated points or separate. Increasing geometric sequences increase by a larger amount each step because, again, you are multiplying, making them larger and larger or smaller as you go, depending on the ratio. The first example, they want us to plot the points so that way we can see the exponential behavior of the points. So I'm going to do the same thing as before. I'm going to plug in my input starting with 0. So 0, 1, 2, 3, and I can go to 4. So when I plug in 0 here, I get 8 times 1/2 to the power of 0. Remember, any number except 0 to the power of 0 will give me 1. So 8 times 1 will give me 8. That's my initial value. When I plug in 1 here, I get 8 times 1/2 to the 1. 1/2 to the power of 1 is just 1/2. So 8 times 1/2 is the same as 8 divided by 2, which is equal to 4. So that will be the next term in my sequence. When I plug in a 2, I get 8 times 1/2 to the power of 2. When I have a power with a fraction, that power needs to be applied to both numerator and denominator. So I'll get 8 times 1 squared, which is 1, divided by 2 squared, which is 4. Again, put it over 1, which is the same thing as 8 over 1, times 1 over 4, which is the same as 8 divided by 4, which is 2. So that will be the next term of my sequence. For the next one, I'm going to input 3. So I'm going to do 8 times 1/2 cubed. Again, I'm going to apply that to the numerator and the denominator. So that will give me 8 times 1 over 8. Put the other one over 1, which will be 8 over 1 times 1 over 8. Multiply across, giving me 8 over 8, which simplifies to 1. For the last one, I'm going to do 8 times 1/2 to the power of 4. So it will be 8 times 1 times 2 to the fourth, which will be 8 times 1 over 16, which will be the same as 8 over 16, which is equal to a half. So 1/2 will be my last one. Now that I have my table, I am ready to start plotting the points. So the first one will be 0, 8. The second one will be 1, 4. The next one will be 2, 2, 3, 1, and 4 and 1/2. Again, we can see the exponential decay shape of the graph. If we were to connect the points, again, do not connect them because they are not continuous, like we said earlier. For example 6, it says for each of the following, determine if the sequence could be geometric. If it is, determine the common ratio. So what I'm going to do is I'm going to create my table just like before, n, and then s of n on the right side, 0, 1, 2, and 3. And then I'm going to start plugging in. So when I plug in 0, in here is 3 times 0 squared. 0 squared is 0 times 3, which is 0. For the next one, I'm going to input 1, 1 squared, which is 1, times 3, which is 3. For the next one, 2 squared, which is 4, 4 times 3, which is 12. And then for the last one, 3 times 3, which is 9, 9 times 3, which is 27. Again, I'm looking for a common ratio. What number multiplied by 0 will give me 3? There is not such thing. So I know it's not geometric already, but if I continue, I know that 3 times 4 will give me 12, and then I know that 27 divided by 12 will give me 27. So these numbers are different, and one of them is undefined, so I'm going to say S of n is not geometric, or not a geometric sequence, because there's no common ratio. Okay, for the next one, I'm going to create my table again. So n on the left, S of n, 0, 1, 2, 3. So now I'm going to start plugging in these numbers. So when I do this, I do 4 times 2 to the power of 0 minus 1, which is the same as 4 times 2 to the power of negative 1. If you remember from algebra 2, every time you have a negative exponent, you can make it positive by sending it to the denominator. So this is the same as 4 times 1 over 2 to the positive 1, which is just 1/2. Put it over 1. That will be 4 divided by 2, which is 2. So that will be my initial term. For the next one, I'm plugging in 1. So it'll be 4 times 2 to the power of 1 minus 1, which is 0. Again, 4 times 2 to the 0, which is 1. So that will be simplified to 4. For the next one, 4 times 2 to the power of 2 minus 1, which is the same as 4 times 2 to the 1, or the same as 4 times 2, which is 8. So 8 will be the next one. And then 4 times 2 to the power of 3 minus 1, which is 2, or 4 times 2 squared, which is 4, 4 times 4, which is 16. So now I'm looking for a common ratio. What number multiplied by 2 will give me 4? That's 2. What number multiplied by 4 will give me 8, which again is 2. And then what number multiplied by 8 will give me 16, which is 2. These numbers are the same. So I know that S of n is a geometric sequence. Because the common ratio is 2. Okay, for C, that gave me the sequence already. So again, I'm going to do something similar. I'm going to go from right to left and divide. 24 divided by 8 will give me 3. 8 divided by 12 does not give me 3. So I don't have to continue further again, because it has to work for every single number. The common ratio has to be the same throughout the whole sequence. So for this one, I know that the sequence is not geometric. because there's not a common ratio. I'm going to do the same thing for the last one. 1 divided by -2 is -1/2. -2 divided by 4 simplifies to -1/2. 4 divided by -8 simplifies to -1/2. And then -8 divided by 16 simplifies to 1/2 as well. So again, I know that this one is geometric. And I know the common ratio is -1/2. You can write it as a sentence, but that's how it works. Okay, example number 7 says let g of n be a geometric sequence where g of 1 is 12, r is 2. Find the expression for g of n and use that expression to find g of 4. So again, I have g of n equals g sub k times r to the power of n minus k based on the equation from the previous page. I want g of n, so this variable will be my k, so k equals 1, and then g of k equals 12. So now I'm just going to plug in g of n equals g sub k, which is 12, times my common ratio, which is 2, to the power of n minus k, where k is 1, so that's just that. The good thing about geometric sequences is that you don't have to simplify. Never multiply these two numbers because this number has an exponent. Once you distribute the exponent, you can multiply them. But when you're looking at the equation, those numbers should never be multiplied. After that, I want to find g of 4, which is going to be 12, times 2 to the power of 4 minus 1, which is 3. So g sub 4 is going to be 12 times 2 cubed, which is 8. And then 12 times 8, which will give me 96. So g sub 4 is equal to 96 will be my second answer. Okay, looking at example number 8, they gave me a geometric sequence as order pairs or a graph. And then I'm using that to find g of n, and I'm using that to find g of 12. So what I'm going to do is I'm going to pick two numbers from the sequence, and then I'm going to say n equals 3 and a sub n equals 1 based on these numbers. And then I'm going to say k equals 1 and a sub k equals 4. Going back to my equation, g of n equals g sub k times r to the power of n minus k. I know that this should be g's. I know that g of n is equal to 1 and g sub k is equal to 4. I know my common ratio needs to be found, so I'm going to leave it as r. And I know that n is 3 and k is 1. So I get 1 equals 4 times r to the power of 2. Divide both sides by 4. I get 1/4 equals r squared. Take the square root on both sides. When you take the square root of a fraction, take the square root of the numerator and the square root of the denominator. In this case, it's going to be r equals, the square root of 1 is 1, the square root of 4 is 2. So r equals 1/2. So now I know that g of n is equal to 4 times 1/2 to the power of n minus 1. After that, what I'm going to do is I'm going to plug in g of 10. So g of 10 is equal to 4 times 1/2 to the power of 10 minus 1, which is 9. After that, I'm going to do g of 10, which is 4 times 1 to the 9th over 2 to the 9th. Don't forget, when you are taking a fraction to a power, you have to apply that power to both the numerator and the denominator. So in this case, that's what I did. I put 1 to the 9th and 2 to the 9th. So now what I'm going to do, I'm going to say g of 10 is equal to 4, and then 1 to the 9th is 1. 2 to the 9th is going to be 512. So multiply 2 by itself 9 times until you get your answer. After that, I'm going to say that g of 10 is equal to 4 over 512. I don't want to simplify because I don't want to make a mistake simplifying it and getting the wrong answer. Okay, looking at the next part. Uh, just a quick reminder, a geometric sequence has successive terms that have a common ratio or R. This means that each term is multiplied by the same number to generate the next. Uh, and then this is the equation that we're going to be working with again. For this example, it says find an equation for the geometric sequence where g sub 3 is equal to -3 and the common ratio is 10. All they want is the equation, so I know that g of n is equal to g sub k times r to the power of n minus k. Again, I want g of n, so this is going to be my k, so k equals the subscript, which is 3, and then g sub k is -3. So what I'm going to do is plug in my k's into my formula and my r. So g of n is going to be equal to g sub k, which is -3. I know my common ratio is 10, and my power is n minus k, which is 3, and I'm done. This one is very simple since I don't have to find anything else, just the equation. Example number 2 is going to be similar to that, where I'm looking for the equation, but I'm also looking for g sub 5. They gave me g sub 2, and they gave me r equals 1/2. So what I'm going to do is I'm going to start with my equation, g of n equals g sub k times r to the power of n minus k. I know that k is 2 and a sub k is 24. So g of n equals 24 times 1/2 to the power of n minus 2. So this is my first equation, and then I want g sub 5, which is 24 times 1/2 to the power of 5 minus 2, which is 3. So that will be g sub 5 equals 24 times 1 cubed over 2 cubed. So that'll be g sub 5 equals 24 times 1 over 8. And then I'm going to do g of 5 equals 24 over 8, which is equal to 3. So g of 5 equals 3 will be my second answer. Okay. We already talked about this. I talked about it on the previous problem because I was trying to bring it up. But you can pause the video and read the box about geometric sequence given two different terms. Like I said, we already did it. So I'll pause it. When you're ready, you can unpause and move on to the last two examples. So for example 3 says let g of n be a geometric sequence where g sub 3 is -2, g sub 6 is 128. Find the equation for g of n and then use g of n to find g sub 11. So again, n equals 6 and a sub n equals 128. K equals 3 and then a sub k equals -2. Start with your equation, g of n equals g sub k times r to the power of n minus k. So in this case, this should be g's, not a's. G of n is 128. G sub k is -2. And then your common ratio, I need to find it. And then I know that n is 6 minus 3. So that gives me 128 equals -2 times r to the power of 3. Divide both sides by -2. So I get 128 divided by 2, which is going to be 128 divided by 2 is 64. -64 because again 128 divided by -2 is equal to r cubed. To get rid of the cube, take the cubed root on both sides. So then when I do that, I get r equals -4 because -4 times -4 is +16 times -4 will give me the -64 that I want. So g of n is equal to g sub k, which is -2 times -4 to the power of n minus 3. After that, I'm going to plug in my 11 to find g sub 11, which is -2 times -4 to the power of 9. To the power of 8. Sorry, 11 minus 3 is 8. After that, g of 11 is equal to -2. When I do -4 to the power of 8, that will give me 6, 5, 5, 3, 6. And then once I multiply that by -2, that will give me -1, 3, 1, 0, 7, 2. Okay, that will be the other answer. Same thing for the last example. They gave me g of 2 equals 48, g of 7 equals 1.5, and I know it's a geometric sequence. Find g of n and g sub 11. To make this easier, I'm going to label first. So I know that this is going to be my n equals 7, and g of n is going to be 3 over 2. For the other one, I know that k equals 2, and g sub k is equal to 48. Start my equation, g of n equals g sub k times r to the power of n minus k. So I know g of n is equal to 3 over 2 equals g sub k, which is 48, times r to the power of 7 minus 2, which is 5. Okay, it looks very complicated, but I'm going to start solving by dividing by 48. So what I'm going to do is I'm going to make 48 into a fraction, and then I'm going to do this on the side. So it's going to be 3 over 2 times the reciprocal of 48 over 1, which is 1 over 48. Okay, so before I multiply this, I know that I can divide this by 3, giving me a 1, and I can divide 48 by 3, giving me 16. So that gives me 1 over 16 times 2, which is 32. So I know that 1 over 32 is equal to r to the 5th. To get rid of the 5 power, get the 5th root. Again, when I do that to a fraction, the 5th root of 1 divided by the 5th root of 32 equals r. So I know that the 5th root of 32 is equal to 2. And then I still have a 1 from the top. So I know that my common ratio is 1/2. After that, g of n equals g sub k, which is 48 times 1/2 to the power of n minus k, or n minus 2. So that will be my equation. And then I'm finding g sub 11, which is 48 times 1/2 to the power of 11 minus 2, which is 9. After that, g of 11 equals 48 times 1 to the 9th over 2 to the 9th. So when I do this, I get g sub 11 equals 48 times 1 over 2 to the 9th, which is 512. And then I'm going to say g sub 11 equals 48 divided by 512. Again, I'm going to leave it like that. You can try to simplify, but if you simplify wrong, you'll get the wrong answer. Well, thank you for watching this video. Hopefully you learned something new, and I will see you next time.